So, hello, I'm Devin Lust, and with me is Jacob Bailey. Uh, and we also have our team, Jumbo Chen and Blake Whitman. We will be presenting AEP's Worker Safety Challenge. Uh, our goal was to create software that helps AEP workers determine the most at-risk sites and allow leaders to quickly take action in preventing human, property, and environmental damage. So how we did it, we created an LLM using open source technology and fine-tuned it to domain-specific nuances with text comments from AEP workers. We developed a dashboard to help safety leaders recognize trends and take proactive safety measures. And we prototyped a mobile app to streamline the safety check process for both those on the field and in the office.
So starting with the model, the main challenge here was that the data we got was not labeled, so we couldn't do any supervised learning techniques. We had to develop a way to label it automatically, and we did this with an aggregation of clustering, tokenization, and zero-shot classifying. And then we generated labels as confidence percentages between 0 and 1 of whether the models agreed with each other. And then a high potential for danger is classified when it likely belongs to one of the 13 pre-identified categories from AEP. Continuing with the model, once we had the labeled data set, we wanted to fine tune a transformer model. In this case, we used BERT. And you can see on the left, the graph here, that was how we chose our number of clusters for k-means. And then on the right, this is our training and validation loss graph for the final fine tuning of the transformer.
So we were able to create a dashboard to model our model. And so we have on this top left, you can see the percentages of high valued comments per category. If you went to this link, we'll post these slides in our repository, you will see that you can hover over and see the percentages. We also have the frequency of high value comments for each category. And we also have the number of high value comments over time.
So in the end, we wanted to make something that was actionable for workers and for supervisors in the office. So we made a mobile app, or at least a prototype. We didn't get too far with this, but we did make a form for the workers so they can conduct their safety checks while they're out on the field. And they will automatically hit the LLM after submission and be able to detect if it's a high risk. And based on that, it can alert supervisors if a high risk is detected. And we also added features to it, such as adding images and the idea to add geolocation based on the image. So in the future, we can do better pattern recognition and better prediction.